Hey there, students. On this clip, we're going to be going over two examples on how to find the values of the six trig ratios when theta is at standard position. Okay, so let's go ahead and write down the title of the notes, the instructions for the notes. So we're so for the given trig ratios, there are going to be two of them. The given trig ratios with theta in standard position, graph theta and the resulting triangle. Okay, and after graphing theta and the resulting triangle, you're going to find the missing side of the triangle, then find the value of all the trig functions. Okay, then find the value of all six trig ratios. Okay, all right. So with that in mind, let's move on to number one. Number one, we have sine theta equals 3 over 5, and because sine theta is restricted to the region between pi over 2. Over 2 is less than theta, and theta is less than pi. Okay. All right. So with this in mind, let's go ahead and graph where theta is first, and then we will construct our triangle. So we know theta is between pi over 2 and pi, so let's draw a coordinate system. So there goes the y-axis, and then the x-axis. Now, we know that pi is 180 degrees, right? So this is 0. So 180 degrees is half a full circle. This is 180, because we know full circle is 360, right? So if pi is 180 degrees, that means this must be pi right here. So if this whole angle is pi, then that means half of it is going to be pi over 2. Right here, pi over 2, which is the same thing as 90 degrees. Okay? So angle theta is somewhere between these two axes, okay, between the positive y and the negative x-axis. So it's somewhere here. So this is not a perfect sketch. We're just going to draw the segment that indicates the length. So it goes something like this. And then this region right here, theta in standard position, is going to be right here. So this is theta. All right. Now we're asked to complete the triangle. So let's go ahead and draw the resulting triangle. That's the hypotenuse of the triangle, and this is another side of the triangle. All right. So now this is a 90-degree angle, and this is the reference angle that we're dealing with. Okay. Now we need to find what size of this triangle do we know? Well, let's name it first, and then we can use this trig ratio to find out what goes where. If this is theta, that means that this side right across theta, this side right here, straight across, this side is the opposite. Okay? This is the opposite. If that's the opposite, this other side is the adjacent. The hypotenuse h is always opposite the 90-degree angle. It's always the longest side of the triangle. Okay, so this is opposite because it's opposite the reference angle. This is adjacent, the other leg, and then hypotenuse is the longest side. Okay? Alright, so how can we connect this names in this triangle to sine? Well, we're going to use SOHCAHTOA. Okay? SOHCAHTOA. Now, from SOHCAHTOA, we know that sine is basically the opposite of a hypotenuse. Okay? Sine is the opposite of a hypotenuse. So, since we're given sine here, sine theta is 3 over 5. We can confidently state that the opposite is 3, the numerator is 3, and then the hypotenuse is 5. Okay? Now this is the hypotenuse right here. All right, so now with that in mind, let's insert the measures into our triangle. Now, since the opposite is 3, that means this side right here, the measure is going to be 3. Okay? And then the hypotenuse is 5. Let's put that in. So the opposite is 3, and the hypotenuse is 5. All right, so we labeled the triangle. Now we need the last side, which is the adjacent. Okay, so we're going to use the second variation of the Pythagorean theorem, which is that a squared plus o squared equals h squared. This is the same thing as a squared plus b squared equals c squared. Okay, all right, so we're looking for we're looking for a. We know that, so we're going to put a squared plus, we know that o is 3, so plus 3 squared equals h is 5 equals 5 squared. All right, let's solve this equation for a. So we have a squared plus 9 equals 25. So we're now going to get a by itself. We'll subtract 9 from both sides. And then we'll have a squared equals 16. We'll take the square root of 16. A is going to be 4. Okay, so that's the length of the adjacent. So it's going to be 4. Now, since we're going 4 units to the left, as we're going to the negative x, that means our adjacent is actually going to be negative 4. Okay? Because we're going to the left. Remember, this is your negative x, this is your positive y, positive x, and negative y. Okay? Alright. So with that in mind, we now have all 3 sides. We're now going to use SOHCAHTOA to finish up the problem. Now we need all 6. We're going to start from the 2 parent trig functions, which is sine and cosine. Alright? So all we just need is look at a formula and use SOHCAHTOA to figure this out. Alright, so from I know that sine theta is opposite of a hypotenuse. We're already given that. We already know that sine theta is 3 over 5. If sine theta is 3 over 5 is reciprocal, cosecant is a reciprocal of that is h over o, which equals 5 over 3. Alright, now the next trig function we need is cosine theta. Cosine theta is adjacent of a hypotenuse. The adjacent is negative 4, and the hypotenuse is 5. So there goes cosine theta. If that's cosine theta, then the reciprocal cousin of cosine is secant theta. And that one is hypotenuse over adjacent. Okay? Now, we can figure that out by simply taking the reciprocal of this term or use the triangle. So secant is going to be 5 over 4. Negative 5 over 4. Alright. Now from TOA, tan theta, and it's opposite over adjacent. For TOA, opposite over adjacent. The opposite is 3, and the adjacent is negative 4. So that's tan. That leaves us with cotangent theta being the adjacent over the opposite. Okay, the reciprocal of tan, which equals negative 4 over 3. So there goes your 6 trig functions. Let's have them organized on the right. Sine theta equals 3 over 5. Cosine theta equals negative 4 over 5. Tan theta equals negative 3 over 4. And then your reciprocals, sine goes with cosecant, don't forget. Cosecant is 5 over 3. Cosine goes with secant theta is negative 5 over 4. And then tan goes with cotangent theta is negative 4/3. So there goes all your 6 trig ratios nicely organized along the right side. Alright, so there you have it. Alright, let's move on to question number 2. So for question 2, we have the ratio tan. And this time we're going to deal with tan. So for number 2, we have tan theta equals negative the square root of 3 over 5. Okay? Alright, so the first thing we're going to do is we're going to go ahead and draw a graph of theta in standard position and then complete the triangle. Okay, so let's draw our coordinate system. There goes the y-axis and then my x-axis. Well, yeah, let me include some more information. Theta is restricted to the region between 3 pi over 2 and 2 pi. Okay, so in order to graph theta, we actually need to have this information. Alright, so we know that this is 0 degrees. Half of a full circle is pi radians. Full circle is 360 360 degrees, which is the same thing as 2 pi radians. So if this is half of a circle, then a quarter of a full circle, or half of a circle, is pi over 2. So just divide pi by pi, have pi over 2 there. This is 180 degrees. This is 90 degrees. Alright? If I add pi over 2 to pi, that will give me 3/4 of the full circle, which is 3 pi over 2. So theta is going to be somewhere between 3 pi over 2 and 2 pi. Okay? So let's go ahead and draw the segment indicating the angle, the area spanned by the angle. So we're going to draw the angle always from the x-axis, okay? Because it's in standard position. So this angle right here is theta. So there you have theta. Now let's complete the triangle and then find the missing parts. Alright, so how do we complete this triangle? Well, we need to use SOHCAHTOA to see what each component of this fraction mean. So SOHCAHTOA. In this case, we have tan, so we're going to be looking at TOA. Tan theta is opposite over hypotenuse. Alright, over adjacent. Opposite over adjacent. So where in this in this graph is the opposite and the adjacent. So opposite of adjacent. So since this is theta, this is the right angle. The side opposite theta is always your opposite. Okay, that's your opposite. The longest side opposite the 90-degree angle is your hypotenuse. And the other side, the base where it sits on the x-axis, is the adjacent. Alright? So, looking at this ratio, the numerator is the opposite, and then the denominator is the adjacent. Okay? So let's keep that in mind. Alright, so let's write it down in a way that makes sense. So, tan theta equals O over A. So O is -3 and A is 5. Okay, so let's put that in here. Opposite is -3. We know that this is one that's negative because we're going down. This is a negative y-axis. Okay, so this is the negative part. The adjacent is +5. Alright, so we need to find the missing side of the triangle. How do we find the missing side of the triangle? We're going to use a SOHCAHTOA variation of the Pythagorean theorem, which is a square, the adjacent square, plus o square. These are the legs of the right triangle, equals the hypotenuse square, h square. Okay, in the Pythagorean theorem, this is a squared plus b squared plus c squared, but using the SOHCAHTOA variation, we have a squared plus o squared equals a squared, h squared. Alright, so now let's plug in the values. We know that a is 5, so we have 5 squared plus the opposite is -3 squared equals h squared. So let's go ahead and get h by itself. So what we'll do, square this, we have 25. Root 3 squared is +3 equals h squared. Alright, we have h squared equals 28. To get h by itself, we'll take the square root of both sides. And then we'll have h equals square root of 28. Let's go ahead and break this down. We want to write it in its simplified form. So what is the square root of 28 in its simplified form? So what we'll do, on the side here, we're going to break down 28. So let's go ahead and break down 28. We're going to take out the prime factors. If I take out 2, I'll be left with 14. Take out another 2, I have 7. So we have 2 2's. So the square root of so these two 2's come out as just a 2 because the square root of 2 times 2 is 2. And this stays behind. This 7 right here stays behind. So square root of 28 is basically 2 root 7. Alright? So my h equals 2 root 7 in simplified form. Alright, let's put that information back into our triangle. And now we're ready to compute the values of all 6 trig ratios. So h is 2 root 7. Alright, so let's do it. So sine theta using SOHCAHTOA is opposite of a hypotenuse. The opposite is negative root 3 over the hypotenuse, which is 2 root 7. But we can't have a square root as a denominator, so we have to rationalize the denominator by multiplying by root 7 top and bottom. So that yields negative root 21. You multiply the radicands divided by 2 root 7 times 2 root 7 is 2 times 7. Okay, that equals negative root 21 over 14. Alright, let's look for the cosine. Alright, how about we look for the reciprocal of sine? If I reciprocate sine, I'll get cosecant, right? Cosecant theta is hypotenuse over opposite. So I'm going to reciprocate this answer I got, which is going to be negative 14 over root 21. Same situation here. We're going to have a square root in the denominator, so we multiply by root 21 top and bottom. And then we're now going to have negative 14 root 21 over 21. We can divide top and bottom by 7. Divide by 7 top and bottom. And that gives me 2, negative 2 root 21 over 3. Alright, so there goes my answer for cosecant. Now let's go ahead and find the cosine theta. Cosine theta is from ka, which SOHCAHTOA is adjacent over hypotenuse. Okay? So our adjacent is 5 over our hypotenuse, which is 2 rad 7. Okay? So we can have a square root in the denominator as we determined in the sine component. So we're going to rationalize the denominator, multiply by root 7 and root 7. And then our answer is going to be, we're going to have 5 root 7 over 2 times, root 7 times root 7 is just 7. So now we have 5 root 7 over 14. Okay? Now, if I reciprocate cosine, the reciprocal relative of cosine is a secant function. So secant theta is to reciprocate this, the hypotenuse of adjacent. And instead of reciprocating the final result, if I reciprocate this, I'm going to have 2 root 7 over 5. So notice that by reciprocating this, I do not have to rationalize. If I reciprocated that, I would have had to rationalize, it makes it longer. Okay, so this is the quickest way. Now tan theta was the original problem. Tan theta is, we don't have to do any work for that. Opposite of adjacent, we know that. It's negative root 3 over 5. Okay, and then the reciprocal relative of tan is a cotangent function. Okay, it's a cotangent function which is adjacent over opposite. So if I do the adjacent over opposite, I'll have 5 over negative root 3. So we can have a square root in the denominator, so rationalize the denominator with root 3 and root 3. So our final answer is going to be negative 5 root 3 over root 3 times root 3 is just 3. Okay, so there goes all your answers. I'm going to organize them so that it's easy to read. So we have sine theta is root 21 over 14. Negative root 21 over 14. its reciprocal cousin, cosecant theta, is negative 2 root 21 over 3. And then cosine theta is 5 root 7 over 14. And its reciprocal relative secant theta is 2 root 7 over 5. Tan theta is negative root 3 over 5. And its reciprocal relative cotangent theta is negative 5 root 3 over 3. Okay, so I'm just organizing all the answers together so that it can be easily read. So there goes your 6 trig ratios when tan theta is negative root 3 over 5 and theta is restricted to quadrant number 4. All right, so there you have it. So thanks so much for taking the time to watch this video. Please subscribe to my channel just by clicking up here. You can share this video with your friends via Facebook and Twitter. More videos can be found on mathreserve.com. Thanks again and have a wonderful day.